Hi, I'm back. I forgot to mention modular programming. Okay, we definitely need to talk about that. You guys, if you take a program that is at all significant and you decide to put it all in one file and compile it that way, you're going to end up pretty much with a mess on your hands, especially when it comes time to troubleshoot this thing, get to the bottom of problems, or if you decide that you want to recode something, maybe change what the user interface looks like, or something along those lines. You're going to end up with a problem. So what we do is we use what's called a modular design approach. Okay, and basically what that means is we take our project, like I said earlier, and we divide it into high-level tasks. Okay, major tasks in order to be able to get to the bottom of whatever outcome we're trying to get. We're going to divide it into tasks. Each of those tasks are actually turned into modules. Okay, those modules may in turn be turned into some submodules. And once you move into the wonderful world of object-oriented programming, you will be surprised at the number of submodules that you create. And the act of creating those things makes it really, really easy to put your program together. But you have to analyze what you're trying to get done in the first place. Otherwise, developing program modules and submodules, probably not going to be able to pull it off. So what are the rules for using modules and submodules? Well, a module will perform a single task. Another thing that's really, really cool about a module is it is self-contained and independent of other modules. Well, gee, Dave, that was really exciting. Why is that so cool? Well, the reason it's so cool is if you write the module correctly and you make it generic enough in nature, you can use that same module in other programs. And the next thing you know, you have a library of modules, which is what all programming languages have. They have libraries. And what they are in fact, or what they in fact are libraries of modules so that they can get things done for you. A module is relatively short. Ideally, the statements in a single module will not exceed 1 page. Sometimes they do, but rarely. Okay, so what's the benefit of modular programming? Well, one of them is it is easier to read. Okay, you look at a module, especially if you're looking at a main program that's calling several different modules, you just simply see the names of the modules, and 90% of the time the names of those modules are actually describing what they do. So it's almost like reading pseudocode. Okay, so you can just follow on down there. You can see the modules that are being called, and you can say, oh, I see, this program is calculating degrees from centigrade into Fahrenheit. Coolness, right? It's easier to design and code and test a program one module at a time, because if the module works, you never have to look at it again. You check your module out, you code your module, or you define your module, you code your module, you test your module, you make sure that that critter works, and once it works, you get to forget about it. Put it over here somewhere, put it over there somewhere, and know that you can faithfully call that module and depend that it's going to properly execute. That means if your program fails, you don't have to look at the module to see where the problem is. You get to look at the code that is using the module, and that is going to really, really speed up troubleshooting a program. Okay? Another thing that's really cool about modules is they can be designed or coded by different programmers. Hand the module off to somebody else. Let them do the job, right? There it is. Designed and coded by different programmers. Let somebody else do this module. Let another person do that module. Right now, I'm involved in a project to where I have to do an application that needs to be distributed across several different venues. One of them has to be a desktop application. The same application has to be a web-based application. And the same application also has to be an Android application. So I divided the project up. I'm handling the web-based portion of it. A friend of mine is handling the desktop portion of it, and I'm providing him with all of the graphics to make sure that there's a uniform theme between the applications. And a third friend is handling the Android portion. I've supplied class diagrams, which we'll learn about later. Well, you'll learn about that next semester, actually. I've supplied the diagrams that they need to make the program go in the different venues. Okay? And of course, a single module may be used in more than one place in the program, such as input. You know, you guys get input in Python, right? Well, you're using the same module, the same single input module. If you need to input data for two different variables, you're using the same input module every single time. Moreover, that input module, that single module, can be used in different programs. It's not limited to the one program that you're working on, which is also pretty cool. Here we have the pseudocode for a sales price program that uses modules. It has three modules. One module is for inputting data, one module is for processing the data, and the other module is for outputting the data. And here we have input, prompt for, all that good stuff, right? Give us a prompt, collect the input, then down here, run the calculations. There are the calculations. They're doing their cool thing. Again, they're setting out there in their own module. Thirdly, we have making these modules right here, or the output module. All right, I'm a little fragmented in my communication because I just realized that it probably wouldn't hurt to write a program that makes use of modules in Python so that you understand what I'm talking about. So I probably am going to append that on the end of these little video series modules, if you will. All right. Once a module is created, we need to be able to call it. We need to be able to use it. Okay, a call statement is what we use to call or to execute a module. And we'll cover that in a lot more detail when I actually create the Python program to show you how that's done. Okay? If we're going to call a module, then we need to have a main module. The main module is often referred to just simply as main, okay? And its job is to provide an entry point for the program so the program can get started, and then call all the modules that we have created. The use of modules compels us to use comments, okay? I have given you an example in previous videos on how to begin to comment your code. At the very, very top or the beginning of a program or a module, we have what are known as header comments. And the header comment usually involves naming the file. It involves what the purpose of the program or the module is, who wrote the module, when they wrote it, and what the version is. Okay. We also use inline comments to indicate the purpose of specific portions of code, which I've mentioned to you guys before, and those of you who have received my feedback from the temperature conversion program have already have already seen that in terms of when I put the comment on the formula itself. Why did you put the formula? You know, what is this formula all about? Well, you need to comment what formulas are all about. Okay. In most programming languages, comments are delineated by 2 forward slashes, which means it's a single line comment, or an open star and a closing star, or an open asterisk and then a asterisk and a closing slash. Right? These here let us know that we can do this on multiple lines. So literally right here, if I wanted to, I could do a carriage return and add stars and stars or whatever remarks that I want to. The key is that anything whatsoever that goes between that and this for most programming languages will be treated as a comment. This is a great little troubleshooting tool, because what I will do is if I'm having problems getting to the bottom of an issue with a program that I'm writing, what I will often do is I will comment out the offending code by putting this just above the code block and this just below the code block. Now, other computer programming languages don't necessarily use forward slashes and asterisks in order to do a comment. For example, Python uses the hash mark, right? And sometimes what a person will do is they will literally use, if you want to do a multi-line comment in Python, a lot of people will just put a quote mark there. So now it's thinking that whatever follows is a quote, or is literally a quote. Python doesn't know what to do with it, so it ignores it. So here's an example of a set of comments that were used in maybe a pseudocode version of Java. Okay, program to calculate the area of in square footage of a room. The programmer is this person, and where they're at, the version is 6 when it happened. It tells what the program does, that it computes the area of a room given its width and length, right? The variables that are used, width, length, and square feet. And then we have a little comment that says declare the variables. There they all are. Then we have another comment that says get the values of the dimensions. It is abundantly clear what we are going to be doing right here because of the comment. See, comments are so cool and they are so helpful. So it's very, very important to use them. Okay, and as you see from these comments that you see here, other than the header comments, these are very, very close to pseudocode, right? They're very close to the pseudocode that you're creating. So we have calculate the square footage, and then down here we have output the result. Now that we've talked about comments, we've talked about modules, we've talked about writing code, it's time to move on to the notion of structured programming. Okay, and my clock is getting ready to run out on me again, so why don't I go ahead and pause here and move into the next video. Okay.